Hello dear learners, in this session our aim is to determine the pH of different soil and water samples. As we know that pH is a measurement of hydrogen ion concentration in a given solution. Soil pH is an important parameter to affect growth of plants as it governs the availability of nutrients to the plants. Similarly, pH of water determines its solubility for nutrients and its bioavailability to different life forms. There are several methods to determine pH of water and soil samples that include indicator dye method, electrometric method using a pH meter and colorimeter method. For routine purposes, the indicator dye method using universal pH indicator solution containing a wide range of pH indicator dyes or paper strips containing pH indicators are preferred, though they are not as accurate as electrometric method. The material required for this experiment are soil samples. Soil samples are collected from roadside, garden and humus-rich sites. Water samples. Water are collected from borewell, tap water and pond water. Weighing machine, filter paper, distilled water, measuring cylinder, droppers, cavity tiles, beakers, funnels, universal indicator solution and pH indicator strips which are narrow and broad range. Now, let's start the experiment. Mark the soil samples collected from different sites as A, B and C. Weigh 10 gram of the soil sample. Add 50 ml of water, distilled water to the soil sample to make a soil solution. This is soil solution A. Filter this soil solution . Filter the soil solution through a filter paper and collect the filtrate in a beaker. Label it as sample A. Take a clean, dry porcelain cavity tile. Mark it as A. Place 5 drops of soil solution A in 3 cavities of the tile. To the 5 drops of soil solution present in one cavity, add 1 to 2 drops of universal pH indicator solution. Mix the contents. Note the color developed and compare this color with the color chart. Do remember that color developed should be noted against direct light. To the soil solution present in the second cavity, dip a small strip of broad range pH indicator paper with the range of pH 2 to 10.5. Leave it for some time. Note the color and compare the color with the chart given. Now, take a pH paper strip with the narrow range of pH paper. Since the color developed is in the range of 6 to 8, we are using the narrow range of pH paper in that range. Dip the pH paper of the narrow range strip of pH paper into the third cavity containing the soil sample solution A. Note the color developed and determine the pH to the nearest possible value with the help of color chart. If we compare the color in the cavity slide A in the first cavity as well as the pH paper strip, we can find out that the pH of this soil sample solution A, it ranges between 8 to 9. Repeat the same steps for determining the pH of soil sample B and C. Follow the same procedure for water sample collected from tap water. Note the pH of the water sample in the same manner. Collect 5 drops of water and put it in first cavity. Similarly, in the second and third cavity. Add universal indicator solution 1 to 2 drops in the first cavity. Mix the content with a different stirrer. And note the pH using the pH chart paper or the color indicated on the pH paper strips. We can see that the color which has been developed in this cavity, it matches with pH 9. So, this water sample is also alkaline. Now, we will record our observation in the table. The soil sample A that we had used, which was roadside soil, the pH that we have obtained from universal indicator solution as well as from the broad pH range paper strip and narrow pH paper strip was between 8 to 9. pH of tap water was also 9. So, the tap water is alkaline. The soil sample given is also alkaline. It is evident from this table that the soil sample collected from roadside shows pH value in the range of 8 to 9. Using the universal indicator solution and broad range pH paper strip, pH was indicated as 9 using narrow range strip, indicating that the soil is alkaline. Similarly, note the pH of soil sample B and soil sample C. The common range of soil pH is from 4 to 8. Soil of pH about 6.8 to 7.2 is considered as good for most of the crops, as it determines the maximum availability of nutrients. For example, iron, manganese and zinc become less available as the pH rises above 6.5, while molybdenum and phosphorus become more available. Alkaline soils having pH more than 7 contain higher quantity of bicarbonate ions, which interfere with the normal uptake of other ions, which affect plant growth. The soil with very high pH or low pH lacks certain nutrients, while others become insoluble and sometimes toxic at extreme pH. Soil pH is also very important for microbial activity and proper organic matter mineralization, as acidic or alkaline soil inhibit microbial activities and slow down organic decomposition. pH is an important indicator about chemical constituents of the water. Water pH determines the solubility of nutrients present in it and its bioavailability to different life forms. It governs its suitability for drinking and for other purposes. Most natural waters have pH value in the range of 5 to 8.5. Rainwater has a pH in the range of 5.4 to 6. More acidic pH, that is pH value less than 5, and more alkaline pH, that is pH value greater than 9, water has adverse effect on plant and animal life. Now, let us quickly recapitulate what we have learned today. Today, we have understood different methods to determine pH of different soil and water samples. We learned about the importance of soil pH for proper plant growth and maintenance of soil microenvironment. We also learned about the importance of pH of water in our daily life. Now, explore the answers to these questions. Find out the pH of waterlogged soils. Why are soils around mineral mining areas acidic? Think about it. This practical exercise will help you to achieve following learning outcomes. Differentiates organisms, phenomena and processes based on certain characteristics and salient features such as type of pH with relative availability of nutrients, soil biota and the type of plants that will thrive in that particular soil type. Relates processes and phenomena with causes and effects based on certain characteristics and features like soil and water pH and alkalinity and acidity of water. Explains systems, relationships, processes and phenomena relationships between soil pH and problem of waterlogging or salinity. Demonstrates to analyze data statistically, represent in tables and graphs and interpret results such as relationship between pH and relative diversity of plants, and appreciates linkages at the interface of biology with other disciplines such as chemistry, agriculture and horticulture. Thank you.